Assalamu alaikum warahmatullahi wabarakatuh. I'm Mohammed Shahid Rahman, a nuclear engineering student. So basically, we're going to talk about how to get inverse matrix in adjoint method from a matrix. To the nuclear engineering people, I have a question. Like, do people actually know that when you use matrix in nuclear engineering field, like, or we can use this such a way that the single matrix can actually reveal how neutron travel to an entire nuclear reactor. So the inverse matrix actually we're going to talk about like isn't just mathematics. It's a map of neutron interaction inside the reactor core. So every element of the matrix tells the story of how a neutron source influences every other location in the reactor. And this is actually the foundation of reactor physics, nuclear diffusion, say advanced simulation code like OpenMC. So stay with me and see how do you get inverse matrix from a matrix. So first thing first, build your matrix. Name it like choose the matrix name can be A, B or C. You can use this bracket, you can use parenthesis, you can use this sign. You can see this is our matrix. You can also take any kind of matrix, but for today's session we must need a square matrix because a square matrix has its unique inverse matrix if its determinant is not zero, like the matrix isn't singular in case. So today in our session we're gonna work with 3 by 3 matrix, and 3 by 3 is actually the said to be the order of that matrix. So here this is our matrix that we are gonna work on. So this is row 1, row 2, row 3, column 1, column 2 and column 3. And here this box is actually showing the index for each of the cell. We're gonna each of the element we're gonna hover by our cursor. Like you can see for this element, for this value the index is saying to be a11, means it's lying in first row and first column. Here for each of the element, uh, this box is actually showing its index. Then next, okay, there are three things. Okay, like this is the formula to get our inverse matrix. So what's that formula? 1 by determinant of A and adjoint of A. So to get the inverse matrix A inverse, we need two things that is unknown, that is determinant of A and adjoint matrix of A. So and there's a red line that you can cross. The red line is that the determinant of that matrix cannot be zero, because if the determinant of that matrix is said to be zero, then we have to say that the matrix is singular, and singular matrix has no inverse matrix actually. One might think that since determinant is zero for a singular matrix, then 1 by 0 comes with infinity, so maybe that singular matrix has infinite number of inverse matrix, but that is not the case. The case is the singular matrix can't has no inverse matrix. Okay, and this is impossible. Okay, having a inverse matrix for a singular matrix is actually impossible. And currently you can see the determinant of our matrix is actually a negative 63, and that is not equals to 0. So inverse exists actually. So first we are checking whether inverse of that matrix is actually exist or not. Then you can see since we have two unknown, then these are the missing adjoint matrix and determinant. And then so here are the 5 steps to find our inverse matrix. The determinant, finding a minor matrix, to be familiar with minor matrix, then getting the cofactor matrix, and then transposing that cofactor matrix, we are gonna get our adjoint matrix and then our inverse matrix to put by putting our adjoint matrix and determinant into formula. Then first step saying to calculate the first step is saying to calculate the determinant. Okay, so this is our matrix, and you can calculate its determinant against any of a single row or single column, any row column. You can see if we choose row 1, the determinant is said to be negative 63. If we choose column 3, then also the determinant is a negative 63, means it remains constant. So you can find determinant against any of the row or column value. Okay, So how do you find actually the determinant? We actually, when you choose a particular row or column, we actually multiply each of the element by their minor. Okay, so then we sum them. So we are actually multiplying 4 by its minor here, and in next step we are going to be familiar with minor. Then we are multiplying 5 times its minor and minus 2 times its minor. So what is minor here? Minor actually, when we say minor for element, this element 4, then we are excluding the whole row and the whole column, and rest of the element going to form a matrix. This matrix and this matrix actually same. So this is minor matrix, and you can see 4, before 4 there is a positive sign, and before 5, like when you are multiplying 5 with its minor, there is a negative sign. This is basically for its position. Since we're gonna use a formula to decide the sign before this element. So the formula is minus 1 to the power I plus j. Here I refers to its row number and j refers to its column number. So for this element, row number is 1 but column number is 2. So sum of 1 and 2 is 3. So minus 1 to the power 3 indicate a negative sign. So we actually place a negative sign here. For this element, negative 2, that we cannot place a negative sign before it, cause row number 1 column number 3, so 3 plus 1 equal 4, so minus 1 to the power 4 equal positive, so minus 2 has a positive sign before it. So anyway, this is how we calculated determinant. We actually did minus 3 times 4 and subtract 3 times 1, and we get negative 15. Okay, here same, 0 times 4 minus 3 times 1 equal minus 3 here. Same goes here. Then we're going to be familiar with this matrix of minor. So when we say minor for this element, we actually exclude the row and the column, and rest of the element form a matrix, and we call this is a minor for that element. If we say minor for this element, we are going to exclude this whole column and whole row, and the rest of the element going to form this minor matrix for this element. For this element, same way we're gonna exclude the row and column, and we're gonna gauge a matrix formed by the rest of the element, and we're gonna say this is the minor for this element. Okay, and next step uh, is cofactor matrix. The difference between the minor matrix and cofactor matrix are exact same, but they differ in sign. Like we put a sign in before the minor matrix and we get a cofactor, and the rest of the procedure is actually same. So when we're saying the cofactor for this element minus 3, we are taking its minor, like excluding this row and column, so rest of the element gonna form its minor, and we are gonna just place a sign before it. By the way, you can say this minor matrix has a value, like we multiply this this way. We multiplied 0 by 3 and we multiply 3 minus 1. So 0 and 3 is multiplied is seen here, and minus 1 and 3 is multiplied by is seen here, and they are subtracted here. So value is 3. So the value for this minor is 3, but we're gonna place a sign before this. So for this position, if you see the sequence plus minus plus, so for this position the sign should be plus. So we are basically placing a positive sign before this, so plus, and the value is 3. So value, the cofactor for this position is positive 3, but same way for this value, you can see for this value the minor is this, and for this minor you can see minus 3 is multiplied by 3 and 3 is multiplied by 1, and we are doing subtraction for in between that, so we are getting negative 12. So we cannot say cofactor for this element is negative 12. We're gonna say, we're gonna place a sign before this. So what will be the sign for this position? The sign is of course negative. Since the sign is negative, since the sign is negative, we're gonna place a negative sign before -12 and the cofactor will come positive 12. So for this element the cofactor is 12. Similar way for this element it is 3, it is 6 here. For this element it is 9. So we have to calculate for the cofactors for each of the elements. So here we got a matrix where each of the element, basically this was the matrix and each of its element is replaced by its cofactor and we got a new matrix. So in next step we are going to transpose this matrix. What transpose means? Transpose means just converting a row from a matrix into its column. So you can say this row and this column exact same, this row, this column exact same, this row, this column exact same, means we are doing transpose by converting row into column. So this was a matrix that we get this by placing each of the element by its cofactor. So we are gonna call this matrix as a cofactor matrix. Then we're gonna transpose this cofactor matrix and this transposed cofactor matrix will be called as adjoint matrix. Okay, so what did you do? What we did, we're gonna summarize the whole thing later. Then next step is placing the matrix and determinant in law. So in law we say 1 by determinant. So in first step we calculate the determinant as -39. So you can say it is 1 by -39 and adjoint matrix. This is our adjoint matrix. You can see the exact same matrix is placed here and we multiplied this whole value with this matrix. And you know about matrix multiplication, we actually multiply each of the element with this value. Each of the element here is multiplied by this value and we get this matrix. And we are gonna say this matrix is our result inverse matrix. So here we are going to summarize the whole process. We got a matrix, this was our matrix, and we get its determinant and we get its adjoint matrix. Then what we did, we used this formula. We did 1 by determinant times adjoint matrix and we get the inverse matrix. Then in next we're going to talk about three mistakes that we do. Suppose you got a matrix and you are supposed to find its inverse matrix, but I already told you that a matrix must not be a singular matrix. If the matrix is singular matrix, that you cannot find its inverse matrix. So you have to know what is called a singular matrix. The matrix whose determinant is 0, we say this is a singular matrix. So we're gonna first calculate its determinant, and if this determinant comes 0, and we're gonna say no, the inverse matrix of that matrix is impossible. Okay, so without calculating the determinant, moving toward calculating the inverse matrix, like adjoint matrix calculation first, is completely hilarious thing. Then we might have a confusion like cofactor matrix and adjoint matrix are same, but you can already see in this step that cofactor matrix and inverse matrix are completely different matrix. This is a cofactor matrix and this is a transpose matrix, adjoint matrix. How did we get it? We actually transpose our cofactor matrix and we get this our adjoint matrix. Then the third mistake that you do, like the sign, we actually do sometimes forget the sign when you are doing when you are actually calculating the cofactor matrix. We actually forget the sign that you're going to place for this value. You can see for this position. So to avoid the mistake for sign when you're calculating cofactor for a element of a matrix, we actually compare this with matrix of sign matrix. You can see for this position you can compare the sign as positive, for this position this is negative, for this position this is positive again. So you can compare and plus a sign before this minus and calculate cofactor for each of the element. So these are the three mistakes. Then comes true false. Say which one is true. Is this true? Like if determinant of A is -39, then inverse of that matrix exists. Of course it exists. Yes, this is true. Then uh, it is saying like, sorry, it is saying that adjoint matrix and transpose matrix are same. No, this is not same. We already saw that. Then inverse matrix and matrix, if the multiplication comes with an identity matrix, you can see here a matrix multiplied by its inverse matrix gives identity matrix of the same order. Same order means row number will be same, column number will be same. And since it's an identity matrix, and an identity matrix is supposed to be like a matrix where value in main diagonal, like this is diagonal, but main diagonal is this. So in this diagonal, values will be 1 and rest of the element will be 0. Then we can call this identity matrix. Then singular matrix has infinitely many inverses. No, singular matrix means it has no inverse value. Okay. And only, you should remember that only non-singular square matrix have exactly one unique inverse. Okay, next. Sixth principle for matrix. Matrix size is m times n. Like matrix size, when you call the, when I will ask you about the size of a matrix, you have to say, you just have to say the row number and column number of the matrix. Like if the matrix has 3 column 3 row, then you have to say like the matrix size is 3 by 3 matrix. So basically it's a matrix and its order or size is 3 by 3 since it has 3 row 3 column. Then there comes this like element for like see, you can see here is a11, a12, a12. Actually we denote the element of a matrix by this way. Here 1112 is not some random number. Here first one refer to its row number and second one is actually its column number. Here second 2 is actually its column number. Here 3 is actually its column number. So these are not random thing. Okay. Then determinant of A is equals to 0 means it's a singular matrix and it can't have any inverse matrix. Okay. Adjoint matrix actually transpose of cofactors. Yes, when you transpose the cofactor matrix, we get the adjoint matrix, and it is true actually. Okay, this is a cofactor matrix, and if you actually convert the row into its column, each row into its column, then you're gonna get adjoint matrix. So the two matrices are not same. Then the law for our inverse matrix. Then matrix multiplied by its inverse matrix comes with an identity matrix. Okay, here's our identity matrix. So that's all for today, for today's lesson. By the way, আমি কেন এইভাবে হচ্ছে এটা শেখানোর চেষ্টা করছি, জিনিসটা দেখো, ম্যাট্রিক্স ইজি, ম্যাট্রিক্স আর ইজি, ওকে, and there are various content on matrix, and my target isn't about on matrix, it's on the procedure, like the way I'm presenting the a topic in front of you, like how I'm presenting, how I'm making you people learn about the thing. So if you people like, যদি তোমরা পছন্দ করো যে কিভাবে এটা প্রেজেন্ট করা হয়েছে, then of course let me know. So if you people really like the way of teaching this matrix, and if you actually have any topic that I can teach you in similar way, like preparing card and make you people learn about that, and of course make me know bell, whatever, click the subscribe button, bell of the person. No, make sure comment your topic. I'm gonna make video on your topic, like what you wanna learn. So bye bye.